All right, here we got the notes for 6.3, adding and subtracting radical expressions. Now, before we get started with this stuff, let's look at something that we are familiar with. Also, I apologize in advance. I know the font is kind of small. That's something I was unable to change for this set of notes. But I'll keep it zoomed in as much as possible so we can see things clearly. All right, so again, before we start with the new stuff, let's look at something we're more familiar with. If we were going to add something, not a radical expression, let's just say something we're more familiar with, like, let's keep it simple, 2x plus 3x. Well, what does that equal? Well, I got 2 of this thing plus 3 of that same thing, so then that's 5 of that thing, so 5x. Hopefully that's not tricking anybody. All right, next, how about 7y minus 4y? Well, same thing with subtraction. As long as these things are the same, I can subtract these numbers. 7 minus 4, I get 3 of that thing. So then that would be 3y. All right, let's say we had something else, maybe 3 stickman plus 5 stickman. Okay, well, what does that equal? Is this going to be any different than these scenarios? No, we don't have to use a letter for our variable. Our variable is just representing a number that we don't know what it is. So if I got 3 of this thing plus 5 of that thing, well, then I have 8 of that thing. So then 8 stickman would be my answer. Okay, so again, it doesn't matter what our variable is. We're just counting how many of that thing do I have. Okay, how about something a little different? What if we had something like 2x plus 4y? Well, what's the answer to that? What's 2x plus 4y equal? Well, it equals 2x plus 4y. I can't combine these things because they're not like terms. Okay, so as long as we have like terms, I don't care if it's an x or a y or a stickman, I can add those things. Okay, so then with that in mind, what would the answer to something like this be? What if I had 2 root 3 plus 3 root 3? Okay, do we have like terms? Sure, I've got 2 of this thing plus 3 of that same thing, so then how many of that thing do I have? In other words, how many root 3's do I have? Well, 2 root 3's plus 3 more root 3's gives me 5 root 3's. Okay, so when we're adding these radical expressions or subtracting, as long as we have like terms, as long as whatever comes after the number is the same in both parts, then we can add or subtract those things. Okay, and keep in mind, we're not changing what we're adding. We're counting how many root 3's we have. We don't multiply the root 3's or do anything like that. That's just how many of that thing we have. Okay, and that's the whole main idea behind today's set of notes. I know we don't have a ton of space. Let's do one more though. You know, because sometimes they look a little more complex than that. It might be something like, how about, we'll try to write small, squeeze it over here in fact, 5x squared y root 7 plus 2x squared y root 7. Okay, do we have like terms? Sure, so really what we're looking for is, does everything after the number match up in both parts? That would be the x squared y root 7 and x squared y root 7. Yeah, those two things are the same. So how many x squared y root 7's do we have? Well, I got 5 of them here plus 2 more of them here. That gives me 7 x squared y root 7's. Okay, so again, as long as whatever comes after the number is the same, then we can add or subtract those. And that's what you want to keep in mind throughout this set of notes. Okay, all right, start filling in the actual blanks here. So, again, sorry about the zoom here. Only like radicals, those which are multiples of the same root or of the same number, can be combined. That's kind of what we were talking about here. As long as they're both x's or both y's or both root 3's, then we can add or subtract those. So an example of some like radicals would be, I'm just making stuff up, 2 root 3 plus 4 root 3. Well, then that's going to give us 6 root 3. Okay? Not like radicals, that'd be something like, how about 2 root 3 plus 4 root 2? Well, those are not like radicals. We can't add those. Okay, I'm going to try to section off what we did earlier. Just put a little box around those there. Okay, so this we can't simplify. That's as simple as it gets. Okay. All right, so it's kind of like the 2x plus 4y. Not like terms, can't combine them. Same thing here. All right, sorry I'm bouncing around the page so much, but again, trying to keep it zoomed in so we can see what we're doing. All right, now this stuff up here is just the mathematical formula. if I've got a of this thing and b of that same thing, well, then I can just add the a and the b, whatever those numbers happen to be. So this is kind of the formula part of it, but don't worry about that. Let's just look at this example. And how do we do that example? Well, do I have like terms? Sure, I've got 3 root 11s plus 7 more root 11s. So then how many root 11s do we have? Well, 3 plus 7, I get 10 of that thing. So 10 root 11. So again, don't change what's under the radical. It's just how many of that thing do I have? And then that's it, we're done. Okay. Number 2, well, part 2 of example 1, I guess. Do we have like terms here on this problem? I got 3 root x plus 12 times the cube root of xy plus root x. And keep in mind, root x, we can think of that as 1 root x if we want to. You can put a 1 in there if you want to. You don't have to. Okay, so do we have any like terms? Yeah, they're not all like terms, but I can combine the like terms that we do have. 3 root x plus 1 root x gives me 4 root x. And then plus, well, I couldn't do anything with that, so it just stays how it is. 12 times the cube root of xy. And then that's my answer. So sometimes you're going to have some like terms and some that are not like terms. Okay? Moving on. Example 2, part 1. Let's see, here we got 4 times the cube root of 5a minus minus the cube root of 3a minus 2 times the cube root of 5a. So then do we have any like terms? Well, yeah, kind of like the last one, the middle piece is all on its own, but I've got cube root of 5a here and cube root of 5a here. So then I can combine those like terms. I've got 4 of them here minus 2 of them here. Well, then how many does that give me altogether? 4 minus 2, I get 2 of that thing, which is the cube root of 5a. And then I still got the minus cube root of 3a at the end there. Okay, so this part didn't change because there were no like terms to combine it with. All right, and then that's it for that one. All right, moving on to the next one. Okay, now they're not all as simple as addition and subtraction like they've been so far. The next one, we got 2 root 50 minus 4 root 8. Are those like terms? Well, not yet. Okay, but can we make them like terms by simplifying? Maybe. So then that's what we want to try if we're able to simplify. Okay, so simplify these individually. Let's see. 2 times root 50, that's going to be 2 times whatever the square root of 50 is. Okay, and then, you know, if you want to show your work, we have some space off to the side. We can do that. The square root of 50. Well, I can break that down. Let's see, 50 is 2 times 25. 25 is 5 times 5. So I have a pair of 5s I can take out of 5. And then what's left over? Well, I got a 2 left over. So 5 root 2 minus 4 times whatever the square root of 8 is. And then we have a little more space. We'll do that over here. From now on, I'll probably just do them in my head for you guys, but if you want to work on these first couple. 8 is 2 times 4. 4 is 2 times 2. So yeah, I have a pair of 2's and a 2 left over. So then that's going to be 2 root 2. Whatever we have a pair of, we can take out. Whatever's left over stays inside the radical. Okay? All right, now 2 times 5 is going to be 10 root 2. And then minus 4 times 2, we get 8 root 2. Okay, now that we've simplified, now do we have like terms? Yeah, I've got 10 root 2's here, minus 8 root 2's. So then how many root 2's do I have? Well, 2 root 2's. And then that's my answer. Okay, so on some of these, we're going to have to simplify and then add or subtract. All right, moving on. All right, part 1 of example 3. Do we have like terms here? Well, I got the 4th root of a to the 5th b. Here I've got the 4th root of 16ab. So no, they're not like terms yet. Okay, but can we simplify these things? Sure, let's see. I've already got a 5 on the outside. Okay, fine. And then I've got 5 a's. How many groups of 4 can I make if I have 5 a's? Well, 1, so then I can take out an a. Okay, so I'm going to put that next to the 5. And then what's going to be left over inside of my 4th root? Well, I'm still going to have 1 a left over and then that b. Okay, and then minus, let's see, here, 16. Now, if we factor that, we get 2 times 2 times 2 times 2. So then the 4th root of 16 is 2. So I can take out a 2. And then we've got the a out there already as well. And then that leaves us with the 4th root of the 16 went out. There's nothing left over. And we got the a and b still left in there. Okay, now look at our problem. Is whatever comes after the number the same? I've got a times the fourth root of ab and a times the fourth root of ab. So then, yeah, these are like terms. So I've got 5 of this thing minus 2 of that thing. Well, then how many of that thing do we have? 3 of that thing, which is a times the fourth root of ab. And then that's my answer. Okay. Last one on the front page here. All right, so again, do we have like terms? No, under the radical here I've got x, y to the fourth. Over here we got x to the fourth and y. Okay, so let's see if we can simplify these and then maybe get like terms. So let's see. It's a cube root, so I need groups of 3. Well, if I have 4 y's, I can make a group of 3 and have 1 left over. So then I can take out a y. I've already got an x out there. I'm going to take out a y. And then what's left over in my cube root? Well, the x that was always there, and then 1 extra y. So xy. Plus, here, same thing, it's a cube root, so I'm looking for groups of 3. Since it's x to the fourth, I can make one group of 3 and have 1 x left over. So I can take out an x. There was already a y out there. And then what's left over inside of my cube root? Well, the extra x and then that y. Okay, now something optional. If there's no numbers in this, I can always say, okay, I've got 1 of this thing and also 1 of this thing. Okay, well, is whatever comes after the numbers the same? Sure, I've got xy times the cube root of xy, xy times the cube root of xy. So yeah, this thing is the same as that thing. Okay, so then how many of that thing do I have? Well, 1 of them here plus 1 of them there gives me 2 of that thing. And what is my thing? Well, xy times the cube root of xy. So then that's my answer. Okay, so then that wraps up the front page, which is all the adding and subtracting. As you can see, sometimes you have to simplify to get like terms before you can add or subtract. Okay, and most of the time, if it's an adding or subtracting problem, we're going to make it so that they do have like terms. So if you simplify and you don't get like terms, double check your work to make sure you didn't make a mistake. All right, let's look at the second page. All right, so on the second page, well, here we're starting to do some multiplication with binomials. So if you have something like 3 plus 2 root 5 times 3 minus 2 root 5, how are you going to multiply that out? Well, how would you multiply out something, let's do something a little different. How about something a little simpler? We don't have a ton of room up top, but we'll make it work. 3 plus x times 2 plus x. Well, we don't have to do exactly the same as what it is down here. But if I just have a binomial times a binomial, and it doesn't matter if the x comes first or not, but anyways, if I have a binomial times a binomial, how do we multiply that out? Okay, well, there's lots of different names for it. The box method, diamond method. The one that I usually use is FOIL. How do we FOIL this thing out? Okay, well, first I distribute the 3 to these two terms, and then I'm going to distribute the x to those two terms, but we'll do it one step at a time. 3 times 2, we get 6. 3 times x is 3x. And then next distribute the x to these two terms. And we get x times 2 is 2x. X times x is x squared. And then I want to combine like terms. We'll just do it right here. Bring down the 6. 3x plus 2x is 5x. And then plus x squared. Now normally we write them in descending order, so it would be kind of backwards, x squared plus 5x plus 6. But the point is, if we have a binomial times a binomial, we FOIL it. Okay? So then that's all we want to do here, is FOIL this thing. So if I'm trying to multiply out 3 plus 2 root 5 times 3 minus 2 root 5, well, first I want to distribute the 3 here and there. So 3 times 3, we get 9. 3 times negative 2 root 5, we get minus 6 root 5. And then next distribute the 2 root 5 here and here. Okay, so 2 root 5 times 3 is going to be positive 6 root 5. And then a positive times a negative is negative. And then this one's a little bit tricky. Here we got 2 times 2 is 4. And then root 5 times root 5, well, that's root 25, which is just 5. So I get 4 times 5, which is 20. Okay. The last thing we want to do is combine like terms. Let's see. First of all, these cancel out because positive 6 root 5 minus 6 root 5 is 0. And then we got 9 minus 20, which gives us negative 11. Okay. Now, so that's our answer. Now, you might have noticed this is actually a special case, which is going to come up quite a bit in this section and throughout this chapter. Hopefully you recognize, well, this is in the form a plus b times a minus b. Okay, so if I have something in that form, and normally we see it backwards, so let's actually think about it backwards. If I have, well, let's just use the formula, a squared minus b squared. Well, how does that factor? Well, we hopefully know that. That's a difference of two squares. That's our formula for a difference of two squares. That's going to be a plus b times a minus b. So normally we see it backwards. Normally we see this thing and we factor it. Well, now we're going to get these two factors and we want to multiply it out. Well, we don't have to do all the foiling if we know it's just going to be the first thing squared minus the second thing squared. That'll save us some work. Okay? So, for example, if we had x squared minus 25, we know that's going to be x plus 5 times x minus 5 when we factor. Okay, now if we were going backwards and we were given these two things, well, I shouldn't have to FOIL this out. I should know it's just going to be the first thing squared, which is x squared, and then always minus the second thing squared, which is 25. So that'll save us a little bit of time. Okay, so let's do one more, and let's do it the correct way that we're going to be doing it this time. If you get something, I'll keep it simple, like x plus 3 times x minus 3. Well, then what's that going to equal? Well, since this is in the form a plus b times a minus b, I know it's going to be a squared, the first thing squared, which is x squared, and then minus the second thing squared, which is 3 squared, which is 9. So without having to do all that work, I know my answer is going to be x squared minus 9. Okay, so this is something that we're going to want to keep in mind, especially on the next set of notes that we're going to do. Okay, but for now, let's just multiply out these last few problems. And then we'll be done. Okay. In fact, we're going to skip to the last two, and we'll come back to this one because this one is not in the form a plus b times a minus b. Since we were just talking about it, let's get these done first. All right. So we got 10 plus root 6 times 10 minus root 6. Again, a plus b times a minus b. So then my answer is going to be a squared minus b squared. So it's going to be the first thing squared, which is 100, minus the second thing squared. And root 6 squared is just regular 6. So we get 100 minus 6, which is just 94. Okay, and if you don't believe me, go ahead and FOIL it out and you'll see that that does work. But again, if we recognize it's in that form, well, great. We just kind of saved ourselves some work. That's our answer. All right. Last one here, and then we'll go back to example 4. Again, we have something in the form a plus b times a minus b. It's okay if the minus comes first. Our answer is still going to be the first thing squared. So I'm going to write it out this way, show a little bit more work. 7 squared minus the second thing squared. And what's the second thing here? Well, 3 root 2. Okay. All right, now what is 3 root 2 times 3 root 2? Let's do this first. Obviously, that's 49. Minus, and then 3 root 2 times 3 root 2. Well, the 3 times 3 gives us a 9. Times, and then root 2 times root 2 gives us 2. So then 9 times 2, we get 18. So this is actually going to be 49 minus 18, which when we subtract those, we get 31. Okay, so we can show a little more work if we want to, but if you can do that in your head, that's fine too. But that's where we're getting those numbers from. Okay, so if you recognize that it's in this form, a plus b times a minus b, that should save you a little time. All right, and then last one here. This is not in any particular form, not in, no formula that we have. So this is the type of problem we just need to FOIL out. This is going to happen a lot too. So here we want to distribute the 4 here and there. So 4 times 3 we get 12. 4 times positive 2 root 5 we get positive 8 root 5. And then next distribute the 5 root 5. 5 root 5 times 3 is 15 root 5. I'm writing it below this one because they are like terms. And then distribute here. So remember, work with the outsides and the insides. So 5 times 2 is 10. Root 5 times root 5 is 5. And then 10 times 5, we get 50. Okay, last thing, combine like terms. Let's see, 12 plus 50, I get 62. Plus 8 root 5 plus 15 root 5, I get 23 root 5. And then that's my answer. Okay, so then that wraps up 6.3.